Plus, just unmute yourself and ask questions whenever you feel there is a need to ask a question. Okay.
Go is not object oriented, but Go will support a lot of the stuff that is supported with object oriented programming. Let's see what that is. Okay. We also haven't seen how structs are defined in Go. This is part of a presentation I had given, I think, 5 years ago, I think. Okay. So, but the basics always remain the basics. There is a struct, 3 structures: attendee, speaker, and conference. Right? One of the first things that we'll notice here is that we are seeing people. You can read it from left to right again. People here, pointer to attendee. So it's easily readable. This is something that we discussed on day 1. The will be accessible from somebody outside this package. Now this gives us an advantage that we can easily have a public and private information, and as you can see already, there is nothing called protected. It just makes life easy. Now by default, a lot of protected is used for exactly protected is used for I don't know what. Typically, when you want to inherit the logic for password creation or something like that, you probably have a protected method which gets inherited but not exposed, stuff like that. Creates a lot of complexity. Don't do anything which is protected, it's not worth it. Okay. There's another interesting thing. Can somebody explain to me what this particular stuff that I've highlighted on the code is? Attendee. This is called embedding. Okay. And this is effectively inheritance. Every speaker is also an attendee. So if you take a struct and add it right inside another struct, it's as good as embedding. Now, time.time is also a struct, but I have called it's a named variable called slot. So what is the difference between just embedding an attendee versus having a slot here? In this particular case, if me is a speaker struct, I can directly access name by doing me.name, exactly like how inheritance works. Okay, but any question so far? Because there is a question which can probably come up here. I can also explicitly specify me.attendee.name. So if anybody had a doubt, that lingering doubt of ambiguity, it is resolved like this. Okay. So to play around this, I want us all to go to Go play in the playground, and I want to build a structure for Hangman. Why not? Just some dummy structure. Okay. Notice one more thing here. Type. So if I specify type of attendee, which is a struct, which is a name as a string. So if you say a type, it will be defined as a type. Mostly this is the same in most languages here also. So let's do this. Type Hangman struct. And what does the game of Hangman contain? Any triggers? We had entries and we had placeholder. Entry would be a map of string with bool. Placeholder would be an array of string. Let's put chances. which is an int. Format the code. Looks good. Now when I want to create an element of the struct, I hope people are also, while you're looking at the screen, I'd like you all to play around and increment. So I'll give you all some additional things that you all can do on your own too. Right? Let's create a game, Hangman. This is one way of initializing a Hangman variable, an instance of Hangman, and entries equal to, not colon equal to. It is just equal to because H is already defined. Make map of string bool and H dot placeholder equal to array of string. I've given you all both the ways of initializing using make as well as using this directly. This is one way of initializing a struct. The other way of initializing a struct would be using string literals. Now string literals can be, I can directly do this. Actually, wait, let me remove this comma. And it will give me an error if I don't print these two things. Can somebody help me fix this problem? Apart from the people who already programmed in Go and got hurt a lot, here are some subtle things. If you are working with Go, these are the nuances of programming which are going to come and bite you in the butt. Because when you are doing this kind of string literal assignments, it's also important to ensure that you put that extra comma there to ensure that it's on a new line. All right. Learn this one. Remember this because it gives you an error which you really cannot understand easily. Everyone who's been programming Go sometimes gets stuck with this, and you're really stuck with this. Okay. Right. So far, so good. Now, I want to create a timer inside the Hangman game. How should I go about it? I've thought of this right now. So even I have no idea how to go about it. So I'm looking for ideas from y'all.
Well, you're going to need some way to increment a timer or a counter based on time that passes.
Right.
So I'm wondering if there's like a built-in timer class or something like that.
And how do we search for that? Let's look at Go packages and search for timer. We'll probably find everything there. Right. So if you look at package time, it supports a timer. And this is how, please, people, notice that I have not even once gone to Stack Overflow or just done a Google search for this. Try to avoid Google search and Stack Overflow questioning as far as possible. I know that y'all will do it in the haste of getting a programming done, but while you're learning, no hitting up or looking up Google or Stack Overflow. Package time, we can look at timer. This is something that I am not going to implement, but I can tell you all this, that I'm going to expect everyone to implement a timer in Hangman so that y'all have y'all either die before the timer runs out or y'all guess before it, just for kicks, right? So we can easily implement a timer like this with a time.timer, and we can see examples here too. I think there should be a timer example here somewhere or a ticker example. tick for 5 seconds and next status update, right? So now this time package is a way that you will find time, duration, all these kind of different packages and different kinds of structures and functions, which will help you really understand how to work with time. Having mentioned time, it is a very interesting factor that when you're trying to format any time format, we always look at the Monday, Jan 2nd, 3 p.m. and this is exactly the date that you will always use as a string formatter. This is another nuance of Go. If you want to exactly tell, if you want to exactly specify what kind of format you want your date to be shown in, you can use Monday as a date, Jan 2nd, 3 p.m., 3405 p.m. and 2006. Okay, if you notice, it is 1, 2, 3, 4, 5, and 6 for the month, day, hours, minutes, seconds, and year. And the day of the week is Monday. Again, these are things that you learn the hard way. You will not realize this earlier until you actually start seeing this hard-coded stuff somewhere, which helps you format it. This was an example of how we actually just go with time. What I would like to do is get some ideas from you about how I can show embedding in this. Type game struct. Name of the player. Name of the game. Intentionally, okay? Okay. Now, will this code really work here? Anyone sees any problems? So far, so good, because I've not made any changes in main.
Name is not declared here.
So here I'll take a pause and ask you all. Name has not been initialized. Should it create a problem? This is me speaking, not the video.
Should not.
It doesn't. It doesn't, because it does not mean that for every variable that you initialize or you declare, it has to be defined when you are creating that struct. Okay. You will hear the same answer as we play the video.
Correct. Good question. Name is not initialized in H1. Does it matter? No, because there. I should actually show you one more way of doing this. All right. There are two ways of initializing a struct. Three ways. One is you initialize an empty struct and then assign each of the whichever variables, the data entities that you want to assign, attributes that you want to assign. The other one is using string literals without the keys. That means just make map string. If you just go this way, I don't have to specify the. Now I have to specify the name. H2. Missing argument somewhere. Oh, sorry, here. What is the difference between H2 and H1? Can somebody tell me what is the difference between the two? I'm only asking so many questions because, guys, I get bored of listening to myself speak so much.
Keys are not specified.
Yes. Yes, Ashwini, what was that?
Keys are not specified in first one, H2.
Yes. One is positional, one is key based.
Yeah.
Perfect. Yeah, and please keep answering the questions like this in the middle. Like I've mentioned in the video also, I am bored of I keep listening to myself so often. So please contribute. Thanks.
Which parameters or which values in H2, or sorry, H1, and in H2 you're relying on the order that those are defined in the struct.
Correct. That means, would this work? Would this work?
Yeah, it should.
It should, because this is a direct string literal assignment by position. This is by keys. So Akshay, your question about we haven't initialized name is fine in H1 because I'm using keys to assign them. It's fine when I'm initializing empty struct, but it is not fine when I'm trying to use direct positional placements. Line number 24, positional placements can make your life miserable, especially if you start changing your struct, which we keep doing often as programmers. Though this works, use it only for structs or simple structs, small structs which work. Preferably go with either a string literal key value based initialization or an empty initialization, whichever you prefer. Okay? Does this answer your question also, Akshay, about name not being initialized?
Yes.
Okay.
Now,
Now,
here, if you got a sec.
Sure, of course.
Whenever we're defining these things, for example, in the hangman struct there, is there a way that we can define a default value for, I guess, an instance of the struct? For example, name in the hangman struct, we know the name of the game is going to be hangman. Can we automatically define it there?
No. So Go does not support default values for structs. You have to do it yourself. Yeah. And actually, let me add on to that question. We are all used to default parameters in functions. Go does not support default parameters. We are all used to default initialization. Go does not support it. The same thing, I mean, it's obvious right now that if it doesn't support default parameters, there is no function overloading. Function overloading in Go is not allowed. Okay? Because it's just to keep the thing simple. Adding one more line to your question, Austin, is that Go does not support a lot of generics. And the reason for that is because generics entail complexity in parsing and loading during the runtime. So a lot of things are to be done manually, and it hurts everyone to do that, but you get used to it. How do I initialize name?
Okay, pass a string Anil or something. We can pass a string for name. Name,
Okay.
Yeah, name Anil, then comma.
Now you're getting to the interesting part.
Hangman.
Sorry, what again?
H1, hangman colon H1 or H2.
Let's not hangman colon what? I don't want to use any of the straight like this, right?
Yes.
Or H2.
Yes.
Fantastic. Aye. Welcome to Go programming. G1, G2. This works perfectly fine. Suppose I want to use this with the string literal way. How do I go about it?
Hash.
Yes, go ahead. If I have to use this string literal, what do I do? Ashwini, you don't answer now. I want to hear somebody else. And should I keep waiting till we get an answer? Guys, how else can we initialize this using a string literal?
I think we can use the curly braces.
Yes, perfect. Just like what we've seen above with H1, we can use all that, and we'll see a few more nuances in that too. Good.
Write the same thing like this. Create the hangman object. So
Yes.
Hangman.
Very important to understand this. That very important to understand that this will not work. Okay. But what will work is this.
There's an error. Can somebody help me out with this error? What's the error?
Comma after the curly braces.
Yes, comma.
After closing.
Yeah, perfect. You'll see me struggle. This is typical programming. You'll see me struggle on the video. Watch.
Where is that new line gone? Line number 42.
All 42 you have to divide.
Comma. Don't forget. These are all the pain points here. Okay. So you can initialize these also. Remember, this is a struct in itself, and game itself is a struct outside. So far, so good. Any questions?
No.
Okay. Now, let me ask a very simple, basic object-oriented question. What is a class?
I have paused the video intentionally. This is part where I actually keep asking, what is a class? People?
I think class is just a feature of object-oriented programming, which just like a struct. I
Not
think.
Santosh. Not you. Yeah, not no, Santosh, not you. Somebody else.
Blueprint for an object.
All right. Excellent. Good answer. Blueprint of an object.
Maybe when we want to connect to not connect when we want to bind the variables with the functions, maybe. So
Yes.
the way of doing that.
I'm so happy you all have given me the right answers, because typical answer that I get is an object is an instance of a class, and a class is the from what an object is made. Correct. And I always have a laugh about it. You will see what I'm actually saying there.
Love asking this question every time. I always get the stereotype answer. So what is a class? Man, everyone's waiting for me to answer. Really? It's not what I ask it, how I ask it sometimes. Everyone knows me well here. Okay. We in a struct have defined attributes. How do we define methods for this particular struct? If I am able to define methods for this particular struct, will it become a class or will it become almost like a class? Go actually supports this by what we call as function receivers. Okay, let's just have a look at this code. Can everyone see my can you see my screen clearly? Yes. Okay. I told you all this session is going to be slightly heavier. There are a few things in this particular topic, in this particular slide, that we'll understand here. One is these two things that I've highlighted in red. Buy ticket can only be called on conference pointer struct. Okay? Which means that we can call C dot buy ticket. This is the first time in the Go programming session till now, we are seeing a call to a method being done exactly like how we do in object-oriented programming with a dot. Okay? This is a struct. C is a struct, conference struct, on which I'm calling a method. Okay? Person.ticket is probably a data attribute here. But I can call a method buy ticket, which will be called on a conference. The other interesting thing is, like we saw yesterday or in the first session, this method returns two data types. And this is very typically how Go programming is done. Most of the methods that you will write will return an error, additional return parameter called error. Now, what is the advantage of that? Can anyone tell me the advantage of returning error every time from some methods?
Error handling.
Yep, correct. One is error handling. That was obvious, Ashwini. Huh? Something else. What else? What is the advantage of returning errors from? And here it's not just errors. As you can see in the method, I'm returning two data types: the ticket string and the error. So what advantage do I get by having multiple returns? One of them being an error.
Easy debugging of the
Correct.
code.
Explain a little more. How is it easy to debug?
Like if we return the error, then we will get to know that from where we are getting the error. We can go back to that function.
Correct. So trace the errors at wherever they happened at source. Good. What else? There is one major huge impact to a language on this. What is that? Rohit, you were saying something?
No, sir.
Okay.
From error code, from where error code, we can define that if function worked or not.
Correct. But that can be done in any. What I'm talking about here, people, is a language changing concept. This changes a whole new concept in this language just because we are returning errors from every function. Let's hear about it. I'm playing the video.
The answer is Go does not require the need for handling any kind of exceptions anymore. There is nothing called an exception in Go. And the reason for this is that anytime you have a method in which you have potentially an exception to be raised, you can return an error, and the error is going to be handled at source. So gone are the days when you will have a big try catch block and then one catch and a finally and all these a try catch, which is a catch all. Because if something goes wrong, you have no idea where it failed from other than by log analysis. But in Go, there is one way and one way to do things right. That's why if you write a method, be sure that if it's going to return, probably throw some kind of error, return an error, and handle the error immediately after calling that method. We will see some of this work in our working code today. The interesting thing to remember here is, again, coming back to our function receivers. Just like we have named returns, we also can name these parameters here. So I can access that person's attendee here, and just like we have called C, I can access anything of the C struct inside this method. Now is an interesting time for us also to discuss and understand passing parameters by reference and passing parameters by value.
Okay, I've stopped the video for a bit. So far, so good. Any questions? Do you realize just because we're able to handle errors at source, all your answers are correct. Debug at source, handle errors. We no longer need any kind of chapter or session on exception handling in Go. There is no such thing. Fair enough. Any questions so far? Okay, I'll continue the video.
When you pass a pointer, you are actually passing a copy of the pointer only. You are not passing a copy of the conference struct. So when you pass a pointer, potentially you may manipulate it. In this particular case, if I had some sort of logic which updates the conference object here, this conference object will get modified because I have passed a pointer. If I want to pass a copy, I will copy that entire struct and pass it. But remember, why remember? Let's play with this. I want to create a function which will called play, which will for our whatever reasons take h1 and g1. Okay, and it will return a boolean which tells me whether you've won or lost, and an error flag which tells me if there was an error. Oops. Okay, so far so good. Who can help me define what this function should look like?
Okay, continue playing.
For this,
Right.
We're not. Yeah.
Correct. So H, hangman.
Games.
Rohit, you have a question?
No, sir.
Okay, could you just mute because there's a disturbance? Thanks.
I've intentionally passed a pointer to it. What next? What are my return values? Somebody else, please. Let's make this more interactive.
Yes, what are the return values?
Boolean and
Boolean and error, correct?
yes.
All right.
Boolean 1 and error.
Good. So far, so good. Should anything need to be changed here? I'm asking for a pointer.
Receiver.
What is given here? Undefined. Let me just move this below. Actually, may I just delete a few of these, or should I keep it for reference? Is it okay if I delete a few?
Yes.
Okay. Let me get rid of these so that we can see all our code in one screen. Okay. Like G2 because it has a lot of data in it. So I'll move G2 on top. Okay. I've asked for a pointer to game. What is G2?
An object of game.
So what do I need to pass here? Okay. So far so good. Everyone has understood why I need to pass the address of G1. Okay. So far so good. Now, hangman has a name. Let me just initialize the name here too. Okay. Now hangman is passed by value. Game is passed by reference. Can I change, if I change any value in name to new hangman? Come on, boy. And G dot name equal to new Anil. Anil, you just got reborn. Okay. And if I print this here, this will give me error. Something missing? Do I need to add something?
You have to call the play away function.
Correct. I have called it.
And you have to use one variable.
I have to use one variable. Or I do this, or what else do I do? I don't care about win or loss here in this case. What do I do?
What do we do?
Underscore.
Excellent.
Underscore.
Thank you. Good. H1G1. Something is missing still. See, I can run this code and you will understand it with the error code. But I want you all to understand that when we code, you code it once, code it right. Thank you.
The return is missing. Yep.
Return true. Actually, if I just return, what happens? I don't say anything for 1 or ERR. What happens?
Default value.
The zero values. Default values, people.
Yes.
Remember, not default. Zero values. Okay?
Zero values.
Yeah. The zero value of 1 and the zero value of return ERR will be returned.
Okay.
Yeah, but only in the case when you have named the parameter. Not if you
Correct.
remove one and error, it will give error.
Right. If you do this, this is called a naked return, right, Anuj?
Yeah, naked return.
Naked returns. If in naked returns, you have to specify something, true, nil, things like this. That's why it is always recommended to have named returns. Okay? Right. I will format the code. Right. Any takers on what is going to be the output here? Yes. What do you think is going to be the output? I'll play it once. To the next.
Hangman and the another string, new Anil, I think. Yeah.
Okay. And why?
Hangman is passed by value and game is passed by reference. Like
Absolutely.
the pointer is passed.
Yes. Can somebody explain this? It is very straightforward. This is basic old school programming. I will explain this one part here.
I can explain.
Go ahead.
So this, you have passed G1 as a reference here. So therefore it got updated, but the H1 is passed by value. Therefore this is not updated.
Correct. So because I have passed what happens here is I'm copying all these values into Hangman. And I'm copying all these values. I'm not copying them. I'm just passing a pointer here. So if I make that change, it gets reflected. That means I'm modifying game. So when you want to modify a struct, pass it by pointer. When you don't want to modify it, pass it by value. So far, so good. Except that there is always some other complexity which creeps in. Okay, I've paused the video here to give you all a prior intimation about what's going to follow. This so far, I can understand that most of you all have found that this is pretty straightforward coding where you pass the address, you can manipulate the object. Now what we are going to look at is how maps and slices are passed and the complexities that it entails and how things change drastically. It is okay if you all don't understand this, but in the middle, if you have a question or a doubt, and I'm sure there will be many, just interrupt me and I will pause and I'll explain again. Okay? Let us have a little more fun here. Placeholder was elephant. Okay. Let's say my placeholder, I'm going to send some random letters A and B. Okay? In both cases, A and B. Right? H dot placeholder equal to, can somebody help me out? Placeholder C. So far, so good. What is going to happen? What do you think should happen?
I guess वो update हो जाएगा placeholder of Hangman because वो शायद deep copy नहीं करता हो.
Only English, please. We have somebody here who doesn't understand even Hindi.
Okay. Yeah. So I guess it will update the Hangman's array, the placeholder array, because it won't have. Maybe it doesn't copy with deep cloning, deep copying.
No, it will not because it is passed by value, not by reference.
That's why I passed it. This is Hangman is passed by value. So Mayuri and Amit, both of you all have two contrasting answers, which is great to see. So I've paused the video. What do you think? Do we have a divided opinion on this?
Since we are appending and the size of slice isn't, the capacity will always isn't given in the main function, so I think it won't have any change. But if the capacity was more here, in the main function, then I think C would have been appended.
Okay, so hold that question. Hold that question, Santosh. Okay, we will look into that part also. That answer is not entirely correct, but we will look into it. Any other takers? You're right. What you're saying is a valid question, but we will actually try this example after. I'll pause this video, get to go play, and I'll share that, and I'll show you what I mean. Any other takers for a different answer? Will it be manipulated? Not manipulated. Hangman is passed by value, and we are trying to change the slice inside it. Let's see what happens.
And the game will update. Game placeholder will update. It is passed by reference. This one will update? Yeah. H1 has been passed by, where is H1? H1 has been passed. Okay. Okay, now let me complicate it a little. Should I complicate it a little more? Just for kicks. Let me try the same thing on the map. Okay. And we will see this time, Amit, you got it right, correct? Okay. What have I done here? I currently have an entry called elephant and I have an entry called ant. You will only have an entry called elephant. What? Amit, in this case, Mayuri was right. H was passed by value. And H1 was passed by value. In spite of that, it got updated. Because it is a pointer. But even slice is a pointer. Why didn't it work? Why didn't this get affected? Anuj, do you want to take this up? It's a very interesting one. Let's see. I won't explain it. Okay. So if you bring less than capacity, I think they can guess the answer. Okay, sir. Tap, right? I am here. Who has programmed like that? Ay. What did I do? Oh, yeah. Can you see line number 24 highlighted? I have printed out the 1 inside the play method for I have the length of placeholder and the capacity of placeholder. Okay. And inside, after this, I have printed out into length of placeholder and capacity of placeholder for the same H1 variable which was passed by value. Is everyone with me here? Yes. All right. Now when you run it, you will realize the difference. In the first case, my length was 3, capacity was 4. In the second case, my length was 2 and capacity was 2. Notice that the capacity changed. When I initialized this particular placeholder here, A and B, it means my length was 2 and my capacity was 2. Okay. When I passed by value, when it tried to...
Oops.
But when I return back, it rolls back the stack, which is why I don't see the changes in this. I know it's a little complicated. I know it's a little difficult to comprehend, but are you all with me here?
Yes.
Okay. The easiest way for me to do is just print the pointers. But if you understand the length and capacity concepts, remember this part that we looked at. I'll tell you exactly what happened to this one. This happened. This was how it was passed earlier, the slice. Can you all see this? It was the same pointer passed, but the capacity exceeded, so it reallocated a new slice. But because we passed by value, it rolled back. But in the case of entries, it's just the pointer which is passed.
One very important thing to remember in Golang is that whenever you pass anything, it's always getting passed as a copy. So it can be a copy of a pointer, like in a case of map. So you are seeing the changes at both the places. But never say that we are passing anything by reference. We are always passing a copy. A new variable will be created in the memory. They may point to the same address. That's why you can see the changes in both the functions. But everything is passed by value in Golang.
Right. I don't want to complicate things a lot more here, but I hope this helps us understand pass by value and pass by reference. When you pass by value, all the copies of that struct are passed. So if that struct contains a map or a slice, you are passing that pointer. But remember that if you want to manipulate anything, please pass by pointer. It's the easiest. If you want to pass by value, you can make a copy of it. But remember, it can still get manipulated if it contains a map. Any questions so far, or should I repeat this entire concept again?
Gautam?
Yes.
Okay. So instead of appending there in the play method, what if I update the second index? So if I was trying to append the third index, I was getting an error because
Correct.
the length of the slice was 2.
Yes.
So if I directly update the second index,
it will reflect the change. Yes. Okay, I'm paused it now because Santosh, you asked this question. I'm actually going to stop presenting and go play for all of us to see this exact same example in a little clarity. Okay, hold on. Okay. Okay, can you all see the screen clearly? Ashwini, can you confirm?
Yes, I can see it.
So here I'm using a slightly different way of creating the placeholder. I'm not using the standard, I'm actually specifying the length and the capacity here. Okay. So this particular line number 17 means that h holder, I'm making the placeholder of an array of string of length 2 and capacity 5. Okay. Now I've set the first element to A, right? And let me also place the second element to B. And I will print it. Okay. So this is a simple example where I hope everyone has understood that even though foo is a method which takes the h1 as a struct, not a pointer to a struct, the array inside is still, the slice inside is still passed by the pointer value. So if you change one of the positions existing within the existing length, it does change. So far so good. Am I clear? I need somebody to answer whether you understood or not. Even though I have passed h1 by value,
the struct got copied. That means the pointer, the length, the capacity, these attributes of the slice got copied. And when I changed something in that particular slice, it actually got reflected. That's why I'm seeing the second row as AX. Okay. Now my length is 2. My capacity is 5. Right? Now, Santosh, I hope this answers your question, that it will get manipulated is within the length. Correct?
Yes.
Now I'll add a little more complexity to it. Now tell me what happens. Okay, so now I will have 3 printfs. One will be before the change, one will be inside foo, one will be after foo. Who can tell me what the output is going to be? Or who can guess? Santosh, what is your guess? What is the output?
Uh, that C will remain in just foo function. It will not be reflected in our main, but X will be reflected. That change we did.
Any other takers?
I think C will be reflected in the main one as well.
Okay. And why do you think
Yes,
C will be reflected?
C will be reflected, I think.
C will be reflected, sir, because the capacity of the
capacity
capacity of the voltage is larger.
Yes, the capacity is 5 and the length is 2. Santosh, do you want to change your answer?
Yes, I want to change my answer.
So you agree that C will get appended and then the output will be AXC, correct?
Yes.
Everyone
That's
agrees?
correct.
Everyone agrees?
Yes.
Dal diya maine.
Yes.
Here is the googly for you. Santosh, your original answer was absolutely correct. And then I got everyone to answer it in the way where AXC, but AXC does seem the logical answer. Am I right? In fact,
Yes.
all of you got it right. Inside foo, I am seeing AX and C. How is it again when it comes out prints line number 26, I'm seeing A and X? Okay. This is the essence of why I get into so many details of trying to explain to you what a slice is and why is a pointer. Otherwise, typical like Ruby programming or any other language has a list, there is just a list. Let me explain to you the internal details here now. So far, so good on line number 24, we just printed A and B. Okay. So now I'm going to get into the details of the struct. H1 length is 2, capacity is 5, and the pointer 0xabcd for sake of discussion. Okay. When it is passed by copy to H1, this H1 is now a copy. So let's also put the address of this guy. This is 0x1234. Okay. Fair enough. This is the address of H1. I mean the memory location of where H1 is, and then H1 will point to the length, capacity, and this is the pointer to the actual data A and B. Is this much clear? What I have kept out in syntactic notation?
Yes.
Okay. Now when I pass this by value, this particular H1 location on line number 11 is different structure than this H1. So it will probably have a different location. Address 0x4444. This is a different H1 who will have length 2, capacity 5, and the address is 0xabcd. So far so good, it's all clear. That's why when we changed an existing placeholder, it went to this particular 0x ABCD plus the length of that string and traversed to the next address location and changed it to X. Makes sense? That's why X got manipulated. That's why you see this X changed here in the last line. Now, when we append, what has changed? When we append this, I'm going to copy this part here. Length has changed to 3. And in this pointer, it went and added A, X, and C. Am I right? So far, so good?
Yes.
However, now when it comes returns from this function foo, does the stack get rolled back? This was passed. This is a copy. So this is going to get rolled back. Now my question to you all is, has this changed? Has this length changed? Because this is a different structure. Address 1, 2, 3, 4. This is different address. We changed here. So the length for me in this particular place is still 2. So even though there may have been some, if you look into the memory ahead of this may be printing C. For the sake of this struct, the length is still 2. Because I passed by copy. If I had passed this, so far so good. Did you all understand why this is still printing A and X?
Yes.
Any questions? Any questions or any kind of discrepancy or like this is wrong, I don't agree? Kirk, I haven't heard much from you. C programming at its core. Thoughts?
Excuse me. Yep. No, I'm mostly just sitting here absorbing while I'm.
I know it's really, really early in the morning. Apologies for that.
Yep.
Yeah,
I'm mostly just sitting here absorbing things, and some of this I've already done, and
perfect.
So I'm just soaking it in, catching the bits that are new, and just sort of riding along.
As a C programmer in your earlier life, doesn't it feel good to see addresses being printed in code?
It's kind of goes interesting that way.
Yes. So has everyone else understood why, though the length was 3 inside the method, it is reverted back only because it was passed by value? Now, if I change the game here and pass this with pointer, that's the only change I have made. Will it work? Do I have to change something in the program? This is the only change I've made.
Ampersand of H1 in foo function.
Good. Who was that? I'm sorry, I didn't see. Who was that?
Rohit. That was Rohit.
Good catch. So if I do this, now what happens? All your answers are now correct. It has got reflected now. Because this address is now going to be 1, 2, 3, 4. Now it will get reflected with the changes. Do you all realize the importance of passing by value and ensuring when you're passing the pointer around? So far, so good. Any questions? Okay. I'm assuming or hoping everyone has understood this part. I'm going to go back to our video and continue. It will probably recap a little bit of what I just spoke. Playing the video.
It will reflect the change.
Yes. Okay.
It should be 1 now instead of 2. Sorry, 1. My bad.
Yeah.
It will reflect the change. Okay.
Okay.
So remember, when we say pass by value, pass by reference, you all have to understand the underlying concepts of what is getting passed. What gets copied is the easiest way. As Anuj mentioned, everything is passed by value. Even a pointer is passed by value. In this particular case also, it's just an integer which is passed, the address. And everything works off that. Even when you place a copy of entries or placeholder, the address of this struct gets copied and sent. But the slices can make a little bit of complexity, but your maps will definitely get manipulated. Okay?
Yes. Okay.
Good. Now that we have seen this, we can very easily, you have understood what is embedding. Now I need to explain to you how we work on a class. Very quickly, let me give you an example here of how we define a function with the receiver. If I say name and all that, like, okay, let me see, render. Okay, and render will return me a bool. Okay, boolean and an error. Now, every game of Hangman can decide how to render themselves. First version. Okay. And if I do h1 dot render, no new variables on the left side. I've already utilized. Oh, okay, good question. Can somebody explain me why this is an error? I've paused the video. Can somebody tell me why it's an error? How do you solve the error on line number 66?
Variable redeclaration. Error is, I think, used before it.
Yes, on line number 57.
It's not finding the new variable.
Correct. So because it is already redeclared, there is no new variable, it gives you this error. This is a very common error you will get. This is a very common error you will face in a lot of places. That's called cloning.
Because this variable is already used.
Where is it used? Here.
The one, yeah.
Not used. It is in this particular case, it is assigned, declared and assigned. So I cannot redeclare it. Okay. Object-oriented programming people, h1.render. And if I say g1.render, this will still work. Notice the difference? Because G1 has hangman inside it, even the methods are inherited. Okay, so everything that you can do in object-oriented programming, you can do in Go. We have looked at.
We have one question which comes up here is, so can you show the render method?
Yes.
I can still see it.
Yeah. Okay.
So render method is defined on a pointer to hangman, right? And you were calling it. Can you show how were you calling it?
I'm calling it on the game object. Game.
No, earlier, before game. I mean, game is a totally different thing. But when you were calling it on a hangman.
Yeah.
So h1 is what? H1 is a value of hangman or a pointer?
H1 in this case is a value, is the struct itself.
Okay, and still you are able to call the render method.
Correct.
Yeah, so
explanation. So every time there are two types of receiver. Let me actually change this to hangman. Okay. H1 here is a struct. Correct? It is not pointer to a struct. I am calling render. I can call the function receiver on a struct or on the pointer of struct. Okay. If this method receiver expects a struct and it is able to decipher that the struct is in place, it will call render. If you are defining a function receiver on a pointer, it can only be called on a pointer or try to resolve it. For example, I'll just remove this lower part so that it's just easy to this. Actually, let me comment this for now. H1.render, will it work? Because I'm calling it on a struct. It works. No problem. What happens if I call that on a pointer? Will this work? Should it work? Any takers?
It will work.
And why will it? Because
you didn't know anything. Yeah. So previously you defined as a pointer and it was working.
Okay, Anil was the one paying attention. Okay, all right. Let's do this. H2 is pointer to hangman. Okay. Should this work now? Should H2 work? H2 is just a pointer to hangman. Exception nahi hai Go mein. There are no exceptions in Go. So should it throw an error?
Yeah, I guess it's not assigned, right?
Correct. So where is it throwing an error?
Invalid.
Okay, invalid or nil pointer being called. So nil, but note where it's throwing an error on line number 76. Okay, so H2 here is a nil pointer. So it's going to say I cannot even call this method. Now what? Will it work? Will this work now?
Yes. Yes, it should.
Everything works fine. What you have to remember is that as long as you are calling a method on a pointer receiver, the pointers will work. If you are calling it on a struct, the entire struct is getting copied. These are utilized for mostly for rendering, where you don't want to manipulate the object. This is used, the function receiver is used, suppose I want to change something in hangman. It will work if I want to manipulate the object. The same way that we had used game here as a pointer, remember the function receiver is also pointers. You can manipulate that struct. In this place, a copy is passed. All the time, whenever you pass either a parameter or a function receiver, the manipulation is only going to happen properly if you have passed it by pointer. The other interesting part that you want to remember is that whether it's a pointer H2 or it is a struct H1, I don't need an arrow anymore. Everything is just automatically resolved with a dot. So far, so good.
So what we've seen till now, right, this particular part of function receivers is somewhere very important. These function receivers that we see are going to be used like class methods or instance methods. Okay. So typically, when in doubt, the decision that you take, whether it should be a pointer receiver or just a receiver, should be based on whether data in that object is going to change or not. So for example, if you just want to print that object, to be on the safe side, always pass by copy. Again, the same rules stand that if your struct has a slices or maps in it, they could get manipulated, but at least by the de facto standard that you have passed a struct by value, the method automatically, a programmer even later on will know that you are not supposed to change anything here. Typically, all your methods that you will pass a function as function pointer receivers would probably be a case where you're actually manipulating the object. So if in doubt, pass as pointer receivers. Any questions on the example that we have seen so far? Okay, continuing.
Would you access the H hangman inside the render one?
So unless I name this as this, or self, you don't need to. You can name it whatever you want.
Okay.
This is a cleaner approach to object-oriented programming. You cannot make a mistake with this. There is nothing left for assumptions. Okay. Any other questions? All right. So now, what is our assignment for today? I'm assuming everyone has a game. Everyone has already got the game built. We'll take another maybe half an hour or maybe 45 minutes at most to get through the second level of this program that we have built yesterday and ensure that the word that we are getting is going to be a random word from an online dictionary. The online dictionary is going to return words, and I'll tell you which online dictionary we are going to use. Do you remember? Yeah, there it is. So randomwordapi.heroku.com/word. It return you some word. Okay, so we just utilized one of these APIs to send a GET request. It said response back a JSON. So we'll be unmarshalling JSON data from there and then proceeding. Okay, in this we will learn how we are working with different packages, especially JSON package, the IO util, and the HTTP package. And we'll be able to generate random words. If we are able to finish that fast, then we'll work with this --dev flag. Okay, it always gives elephant so that we can test. Okay. All right. So what are we going to do today? Like I mentioned here, I have given you all the hints and I am not going to do any coding today. That's it. People, you all have to tell me what I need to type. I will only be a dictaphone today. I will give you the hints. Is everyone with me here? Are you all able to see my screen? This is the easiest way to get information from HTTP. http.get. This is the example that we need to work with. Am I right? So what is this first line? And are you all able to see my screen? I've highlighted the lines I'm explaining. The first line says an HTTP GET, which is going to send a GET request to example.com and get back some response. This response is a struct. Okay, with the HTTP response struct. Defer is a method which helps us ensure that at the end, anytime before the function returns, this is as good. Treat this in as in Java is finally. Defer is effectively a method which is going to be the one which is going to be deferred till the function returns from here. This is usually taken up when you want to have open files. Suppose you do file open or socket open, and when you want to return from the method, you want to close it. We'll also talk about channels in the next session, where you want to close a channel after it's used. Okay. So this response.body is HTTP response body, which is a file descriptor. That's why it is important for us to close it before we return. IOUtil is the next one that we have to look at. IOUtil is also a very interesting package, which is for input-output utility functions. It's that simple. Okay, so you're going to find a lot of cases where you are going to need to use IO, and that's how it helps us out. Trying to see what are the different variables, what are the different examples, will really help you all if you all are trying to see. Read all is an example of trying to read from something. Could be a strings reader, but read all is basically going to go and read everything till it encounters an end of file. Okay. So let me get that URL. Where is that URL? I have pasted this URL in the chat, and just for our sake, I'm going to return from println body. So far, so good. I've pasted the URL in the chat. So for those who want to continue coding on this right now, we can code this together while you are working. The URL is there for your reference. Just to ensure that the game doesn't screw up completely. Is everyone with me here?
Yes.
Any questions? What do I do if there's an error?
You need to import HTTP and IOUT.
Sorry, what?
You need to import HTTP, right? And IOUT?
Yes. There they come. Okay, it's not just HTTP, it's net HTTP and IOUtil.
Okay.
Okay. If there is any error, return elephant. So let's see what gets printed here as the first step. Okay. This is what body has. So it's returned me an array of bytes. So what do I do? How do I see that? Instead of doing ln, let me do printf %s. Okay. Unless somebody has some other ideas. Now it's showing me some word, but what is this word? Whatever. Incitements. Anyone know what incitements are? I have no idea. But it sent me incitements. But here's the thing. The body is printed as a string. This is JSON. This is an array of one word. If I look at this word, I can actually send this to. That means if I add number equal to 5, this should do something. Correct?
Is it the character count?
No, word count. Here is the case. If number 10 is where number equal to number is the number of words to be returned. So I can figure out from here, people, that this is a JSON array always. Correct? Okay, now if it's a JSON array, how do I unmarshal JSON? That means I go to my next package. Now, even though I can easily click on this, it's very interesting to see that it inside an encoding package, and you can have packages inside other packages. And these are all the different types of encoding that is supported in Go right now. And you can have your own. There. This is what we want to see. Okay. I will come back to that example. Here is my byte array. Remember, can you see that a back quote is being used for a multi-line string which supports formatting? I will repeat. A backtick is utilized for a multi-line string. Okay. It is formatted JSON array of objects. That name and order is coming in the same way, and I'm going to exactly unmarshal it like that. Okay, this example is easier. So it is important that the struct that we try to unmarshal it into has exactly the same kind of format that is expected from us. In this particular case, I have an array of objects. In my JSON, I have an array of objects. Is it clear so far? People, is it clear so far?
Yes. Yes.
Okay. Only 2 people it's clear. This is an array of strings. If it is an array of strings, what should I code? What should it be here? What should I try to unmarshal it into?
Slide.
Correct. So, words. Okay. Now, now I want to unmarshal it. Error equal to JSON dot unmarshal body, that is this body, into the address of words. Okay, exactly like this line. If error not equal to nil, handle error, return elephant. Line 6. Okay. Yes. So this is one way of doing this. I could also have done this as like this. Okay. This will also work because I'm passing the pointer here. JSON unmarshal is going to look at it and see if it's assigned, reassign it. If it's just a variable, allocate it. So it will handle that allocation part for us. Okay. And I think there is a lot of cases you just use where, because what's the point of allocating it? What is the point of allocating it and then reallocating it? Right? So now I have got words. So now my fmt dot println words should just work as is. Correct? Let's hope. I might not go undefined JSON. I'm using Vim And I have a Vim configuration which can go and import whichever packages from the standard library is. That's why these are easier, but otherwise you have to go import it yourself. This is my JSON string. Okay. And this is my Go struct of strings, array of list of strings. Okay. Yes. So far, so good. What do I want to return? Return what? 0. And my game will just work. Play the game. Not yet. Word 0. Want to play the game? I'm helping a lot because it's actually showing me the word. My God. I don't even know what nice is. But I think that's the word. Okay? Does anybody actually want to play the game? That would be a lot of fun if I just remove this, right? Here is the thing that I want you all to help me out with. I want to return, I've taken 5 words, but let's return a word which is between. So before we continue, have you all been working with the code on this? I know that this time the video was more intensive, but has anybody been trying to work on this game on your own and trying to update? Any doubts, any questions?
Gautam, I have a doubt.
Yeah, sure.
What if we didn't use that ampersand in the words because slice is just a reference?
Right. So for the JSON unmarshal, right? Santosh, for the JSON unmarshal, you mean, right?
Yes.
So the idea is that if you are, I'm declaring a variable for array of string, for a slice of string. In this particular case, the allocation needs to get into that particular variable declaration. That's why unmarshal requires a pointer to whichever struct you're passing it. Otherwise, the same problem that we saw earlier, the copy will get passed, copy will get updated, but when the stack rolls back, the original structure is not manipulated. So we always have to pass that ampersand. If you don't pass the ampersand, the word string, the words array will still remain empty because it will just roll back the stack. And play around with it, you will figure it out. It is to be honest, it's a very common mistake you all make. We all make this mistake every time, and you have to get your fingers burnt once to get it right. Okay, understood?
Understood.
Okay. Good. Any other questions? Anyone been trying to play this game, make the game while the video is going on? And now here is the weird part. You can't just rely on the recording because sometimes the recordings also don't come up right. So you have to actually concentrate in the training. Any other questions? All right, so I'll just continue. This is the last 3 minutes left of the video, which is just certain subtleties to the game that we are adding. Okay.
5 and 8 characters.
Sorry, I'll just rewind a little bit so that you'll get context.
Want to return, I've taken 5 words, but let's return a word which is between 5 and 8 characters. Fair enough?
Yes.
Word. ऐसा बोलो. Range words.
Words.
Then check the code.
If less word.
And
If word is greater than 5 and less than 8.
correct? Simple. Okay. Otherwise, if all the words are bigger than this, then what? Return word 0. Fix it. I is not used. You notice that it will not let me continue until I get it right. This feels so good. Okay. And now this game has suddenly become randomized. So I can actually work with whatever I want. Make sense?
Yes.
Okay. But when I'm testing this word, how do I test it out? Okay. So before we get into the testing part, I know you all will need a little bit of reference. On the chat, this is the second link I'm pasting of the gist. This gist will give you an idea about everything, right from the get word code to the using a struct, using receivers, everything in this, including there are a few channel work also in this. Use whatever reference you had, especially the get word function, so that you'll get your function program completely running. You can have a look at the rest of the code also. It's pretty interesting. Okay. The last part of this video is a self-help thing. I intentionally do not show the part that is going to follow here on. And this will probably be your weekend assignment if you have the time. Pretty quickly help me implement the flags, the package flag. Command line parsing is done with flag. Can you all implement it in your program directly? What I want is it should work like this. If I give hangman minus def, it should always be elephant. Okay. And if I don't give minus def, it should give me a random word from the net. This is something else. Okay. Understood?
Yes.
Go to flag package and you will find it there. Straight up there. The main usage is very straightforward. Make sense? My favorite function, foo. Okay. This is probably your assignment of the weekend of trying to get the flag implemented. It is very straightforward. And it will be great if on Monday we can see the entire programs working. And I will share, I'd like it for you all to share the screen yourself and showcase the game. Have you all understood what I'm saying? On Monday, before we start the session, I'd like it if some of you all who want to showcase the game, share the screen and let's play a game and see how you've written your code. It'll be great. Okay?
Yes.
Okay.
Yeah.
All right, great. So, run for it.
Yes.
Okay. The last part is just a little bit of stunt that I was trying. So just enjoy this part. I equal to 1. Okay. What should get printed? What should get printed? What do you think? We looked at defer briefly. For those who are listening, defer is a method which is like the finally block, or which will get called only when the function is going to return from any point. It will always get executed. People, what do you think is the output of this program?
3 and 2.
3 and 2. I've got second answer 3 and 4. Any other answers?
Hello world. 3 and
Hello
2.
world. Oh wow, all right, that's now giving it 3 and 2. Why 3 and 2? Why not 3 and 4?
So, defer statement, we write the statement. This execute the last.
Correct. So why 3 and 2 and not 3 and 4? Somebody else said 3 and 4, correct? That seems more like a logical answer to me. Who said 3 and 4?
I think that I will be used.
So defer is going to be called at the end. So basically all these lines, I equal to 1, I plus 2, this I, and then this line is going to get printed. So should be 3 and 2 or 3 and 4?
Is it that I is initialized for 1 and then differ is initialized after I is set to 1? That's why it is 2. It should be 2 at the end.
I've defined a function foo.
Good. Good, Ashwini. I'm glad that nobody is falling for my googlies again. Watch.
A very local variable I as 1. I've called defer. Then I have called I've incremented I by 2. Then I've printed I. What should be the output? Any takers?
3 and 2, sir.
Why 3 and 2? Because it's evaluated at this point. At this point, I is 1. So 1 plus 1 is 2. And this method note is getting executed later on. Then I is getting changed. Then you are printing 3 and then 2. So it's not 3 and 4. This line gets evaluated. It's important to understand this also, that defer will get evaluated when it is declared, but it will get run when before it exits the program. Okay. So on Friday, think about different ways of how we can add maybe a timer such that we have to finish the game of Hangman maybe within a minute or something like that. Okay. I've already given you the time.package. Play around with it. If you have no ideas, we'll work it out during the session itself. Any last questions from anyone? All right. Okay, then see you.
So that's the end of that video. That is probably the end of our session 2. But I think I've got a good idea about your weekend task if you all have the free time. One is the -- dev flag. And if you have it, go make the ticker. The gist that I have shared with you, has that ticker implemented. I would recommend, don't look at it. First, try it on your own. Look at the time package. You will find information about it. And then send me, if possible, showcase something on Monday when we have the session with something of your own innovation. 3 things I'm looking forward to on Monday from people: the -- dev flag, implement on your own. If possible, put in the ticker code. And thirdly, let me see how creative you all get. Figure out something and we'll showcase it. On Monday, we'll have our session at the usual 5:30 p.m. Okay? Not half an hour earlier like we did today, but we'll have it at 5:30 p.m. We are going to discuss channels and Go routines. So whether we like it or not, that session is also going to be relatively heavy on concepts because it's important for us to understand this. If you have implemented the ticker, understanding that session will probably be easier because you would have already heard about channels. Okay, before we end, any last questions?
Gautam, I have one question.
Sure.
So in our program, if I want to move that get word method to another file, let's say I want to make it as utility function, which can be used across the file. So how would I do that? Do I need to make that as a package or what?
No. So every file in Go has to be in a package. The only most important package is package main. So if you write package main at the start of your file, if you open your code now, so you'll see package main.
Yes.
If you open a separate file, say utilities.go, and write package main, it will be part of the main package. That's simple. Okay. If you want to organize your code properly, then you can probably create a folder called common or util, and inside that have all these files under a new package called package util. Just like what we've seen, like HTTP net. HTTP, if you look at the source code, you will see HTTP is a folder. Inside HTTP, you will have a net folder. All the files inside that folder will have package net. So when we import HTTP/net, it's actually a folder structure that we are importing, and all the packages are organized in that format. Okay.
Okay. So in the same import, we can add our package name.
Yes.
Right. Okay.
Yes. Not the same import, we can add our package name. That means you have all your files with the same package main. In suppose you have 3 files right now, all 3 files in the same directory can have package main, package main, package main, and they'll be able to call each other's methods, no problem at all.
Okay.
Okay. Cool.
Okay.
Any other questions? Okay, so I'll see you at the next session. Hopefully somebody will be able to showcase the program of Hangman and be proud of it, preferably with the -- dev flag, if the ticker, if possible the ticker, and maybe something of your own creativity. Okay, thank you so much. See you all on Monday at the usual time of 5:30 to 7. We'll keep it to 1.5 hours only. So enjoy your weekend and happy sleeping. Bye-bye. Thanks.
Bye.
Bye.